Okay, we're given a little bit of information about a triangle. We're given that tangent of an angle A is 5 over 12, and we're given that side length B is 6. So as we get going on this, we want to draw a nice right triangle to begin with. So we're going to make it a right triangle. Angle C tends to be where we go ahead and put it as the right angle. Side length C is going to be our hypotenuse across from this. We use lowercase letters for our side lengths and uppercase letters for our angles. I'm going to go ahead and put A here, little a here, big B, little b on opposite sides. Okay, so the information we're given there about tangent of A equals 5 over 12. And that side length B is going to equal 6. All right, so I'm going to go ahead and label side length B is equal to 6 to begin with. Now the tangent of A equals 5 over 12 only tells us a ratio. All right, it doesn't tell us that the opposite is going to be 5 and the adjacent is going to be 12 necessarily. Instead, it's simply a ratio to help us set up, right? I'm looking over here at tangent is opposite over adjacent. Okay, so if I want to next label my sides, I'm going to go ahead and say, well, if I'm looking at A, all right, I'm focused on this side length or this angle A, what's going to be opposite there is going to be side length A. So just labeling that. And then our adjacent is going to be this 6. The adjacent, meaning that C is going to be our hypotenuse. No surprise there, I'm hoping. But how we can use tangent of A equals 5 over 12 is we can set this up into an equation. We can say, well, that's going to be the opposite, in our case A, over the adjacent, in our case B, but we know that B has to equal 6 based on the triangle. 6 is the actual side length in the triangle. 5 over 12 is just a ratio. All right, so be careful with that. Next, let's go ahead and try to solve our equation down for get A on one side by itself. So we had 5 over 12 equals A divided by 6. All we need to do is we need to multiply both sides by 6. Multiplying by 6 and dividing by 6. And maybe it looks like I wrote a B. I was trying to write a 6 down here in our denominator. Multiplying and dividing by 6 will counteract each other, thus giving us A on the right-hand side all by itself. Now you could leave this as 30 divided by 12. Right? Think of that 6 over 1, multiply numerators, multiply denominators. But we can do a little bit better than that. We can do 5 over 2 because both of those are multiples of 6. All right, so 5 over 2, 2.5, is going to be our value for side length A. Now we still need to find side length C. So finding side length C, we could use one of these trigonometric ratios, or can we? We don't know any of the angles, so we're a little bit stuck there. All right, we only have that one trigonometric ratio for tangent. We kind of used it up already. So the next thing I'm going to go ahead and suggest we utilize is referred to as the Pythagorean Theorem. Different versions, we can call it the Pythagorean identity in different situations, but that just goes as a squared plus b squared equals c squared. Well, we know a and we know b, right? We know a is 5 halves. We just found that. Plus b is 6, so we can square that. And we don't know c, so we only have that one unknown. We don't know what c is still, but that's okay. 5 halves times 5 halves, when we square it, it's going to give us 25 over 4, right? 5 times 5 over 2 times 2. And then 6 squared is going to be 36. And I'm going to go ahead and think of that as 36 over 1, because we have another fraction on the left-hand side there. It's probably going to be cleaner if we go ahead and get a common denominator and make these into a single fraction. So I'm going to go ahead and suggest we multiply by 4 over 4 here. That way our denominator for both these fractions is going to be a 4. Then we have, 25 fourths plus 36 times 4 makes 144 over 4, right? 1 times 4 makes 4. So I'll have our c squared on the right-hand side. Let's go ahead and combine these together. Keeping that common denominator of 4, we'll work 25 plus 144 makes 169. Write the right thing in our numerator here, 169. all over 4 equals c squared. Now we still have to get c all by itself. We have to get rid of that square. So let's go ahead and apply a square root to both sides. All right, now typically when we apply a square root to both sides, we're thinking absolute value. We're thinking both a positive and a negative case. But in this case, because c is the side length on a triangle, it wouldn't make sense for this to be a negative value. So we end up with c on the right-hand side, and we can apply a square root to the numerator, right, by itself. The square root of 169 works out to be 13. And apply a square root to the denominator by itself. The square root of 4 works out to be 2. So that means our value for c, our hypotenuse, is 13 halves. 13 divided by 2. And at this point, we found all our side lengths, which is what the end goal was on this problem. So I hope this helps out. We're not going to be able to find in a nice way what our angles are, A or B. We could use some tangent inverse or sine inverse. Don't worry about that on this example. We were just tasked with finding the side lengths for this triangle. So I hope this helps out. Good luck.